Well, hello, everybody, and welcome back to the South Dakota Forest Health Workshop Series. I'm your moderator, Tony Seidel, and we're joined with your host, Dr. John Ball. Today, we'll be discussing herbicide carryover and drift injury in trees. A lot of us are familiar with herbicides and what they may be used for, but we might not know the impacts to our other woody plants, sometimes unintended impacts too. This has been a very tricky topic in recent years, and Dr. Ball is hoping to explain some of the controversy and to get into some of the details about what we might be seeing and what to do when you do or when you might consider drift injury on your property. Thank you, Dr. Ball, for your time today. If anybody has any questions, we will have time towards the end of the workshop. Please feel free to put those questions in the chat. I'll go through those as they come in. We're also curious to where you're listening from. So if you want
Yeah.
to add in the chat box where you're viewing from today. That always helps us get an idea of who's participating. Um, our workshop is being recorded. For those of you who were on the call before we started, you might have heard Dr. Ball and I talking about our Forest Health YouTube playlist. All these workshops get recorded and go onto our YouTube channel where they can be used uh, to uh, to help with future education. Lots of good information up there. I think there's 18 videos up there right now, all on different topics that we've done in the past. Um, this live workshop does is available for ISA certified arborist credentials as well as Society of American Forester certified forester credentials. If you are a certified arborist, you have to wait to the end of the program. Dr. Ball will present the code for the workshop, the CEU code. You'll have to use this specific title of the workshop along with that code in your self-reporting to get your credential. If you are an SAF certified forester, please put your certified forester number in the chat box. I'll make sure those get in the right hands to report your credentials there. I believe I've covered just about everything. So with that, I'll hand it over to you, Dr. Ball. Thank you.
All right. Well, thank you, Tony, and thanks for moderating these and doing all the behind the scene work to get them all set up. So, good afternoon, everyone. Welcome to the series. We're having delightful weather in Brookings, South Dakota right now, but snowstorm this weekend, which is pretty typical of the Northern Plains. But we all know spring is coming. And with that, I know I'm going to be getting herbicide calls. So, we thought we'd get it started with that. This is one of my very common calls. Why is my tree dying? And since it's a blue spruce, there's many possibilities. But one that I'm frequently asked is, did somebody spray? And so let's kind of go through how complicated this issue is and how we can work at trying to figure out if herbicide is one of the possible culprits. Well, first of all, this is not CSI. I wish I had a CSI lab. I wish I looked as good as all the actors that play these roles and that we could do everything within 30 minutes and solve all problems, but we can't. Our lab is a little bit more basic. There's welcome to CSI or for Brookings, but I'm going to go through the process here. Well, first of all, process starts with a sample. And I love that this is one of my favorite boxes for a sample. Warning, contents may cause happiness. Not a chance. It doesn't matter what's in that box. It was sent because somebody wasn't very happy. So let's go through this. I've got two things up here. First of all, mailing any sample, plant sample or herbicide sample, mail on a Monday to a Wednesday, so it doesn't spend the weekend. And for herbicide, that's in the dark there, send overnight. Now, herbicide samples are in a paper bag. Oh, we want them to dry out. That's the point. But keep them frozen till sent. One of our biggest issues is someone collects some samples, they put them on the dashboard of their truck, and 3 days later, when they're all crinkled, then they decide to mail them in. But notice here, paper bag sent overnight. But a real key thing is that third line. Do not send samples unless asked. Please do not send samples until asked. The first thing, we would like a regular sample as a pest sample. That would be sent in a plastic bag with a dry paper towel. And you might say, well, wait a minute. Why the difference? Well, first of all, we have to determine whether it is herbicide, or let's say it's likely to be herbicide. If you send a sample in a paper bag, excuse me, in a plastic bag with a little piece of towel, we're not going to analyze that for herbicide, typically. What we're going to do is look at it and say, well, are there any other symptoms and signs that might be associated with an insect or a pathogen or a mite, possibly? And let's clear those off the table first. Lots of times we do get samples that really there's no indication that it could be a herbicide. And in fact, we can find symptoms and signs that relate to a insect, mite, or a pathogen. And we go down that route first before we go through to look at herbicide. Now, we might go through all that and say, you know what, this might possibly be herbicide, collect samples this way and send them in. Or we might say we're going to come out and take a look at it and then collect the samples ourselves. What's always a problem though is when people just send samples in and say, we think it's herbicide. Can you analyze it? Well, we may not be able to without more specific instructions to you in how to collect them, or have myself come out and collect them, or perhaps somebody out from the Department of Ag and Natural Resources to collect samples are under our instruction. But I thought you might get a kick out of knowing, well, what happens when you do send a sample in for herbicide? Well, the first thing, and it's a little bit of overkill, is at the local lab there, liquid nitrogen is used to shatter that sample you send, that frozen sample, into very small fragments. It's literally reduced to powder. Okay, so the plant tissue is down to powder. And so it's homogenized to ensure that we get a very even extractant. So first thing, dried sample that's fresh and frozen, kind of like fish. And then it's going to be pulverized down to nothing, powder. Well, next step, or one of the steps is then extracting with a suitable solvent. In other words, okay, how does that have to be broken down? Now, it has to be filtered. It might have to be broken down several times. So it's not a very fast process. It's not like shatter it and mix it up into something. But that's the next step. Well, then at the end, there's your sample. I thought you get a kick out of that. You send an entire bag, a quart, maybe 2 quarts, half-gallon bag of leaves under our instruction. That's what you're left with. A little liquid in this case, that's now going to be analyzed. And that's going to be analyzed using a liquid gas chromatograph or liquid chromatography. And again, it has to be matched with appropriate standards so we know what we're looking for. And we can use liquid, we can use gas. All right, both those are possibilities. And then once that's done, still not done. Now there's a lot of math to go through and compare it to the standards. In other words, what should be the peaks that we would get for a particular chemical or a particular family of chemicals, if you'd like. So the detective work goes all the way through. This is not a simple take a leaf, run it through a machine, and it all comes out. Now, the other thing I'd like you to know, the entire process from a bag of leaves to results is 3 days. That's if there's nothing else to do for those 3 days. And there's no other need for these machines that are in high demand. So in the perfect world, the world none of us live in, from the moment the sample comes in and that is if nothing else is being done, everybody's total job is focused on this sample. It's 3 days. And that's why in reality, it's more like 3 weeks. And it can sometimes take longer. We've had it where sometimes it takes 6 weeks from the sample to the end process. And occasionally can even go into 2 months. But I would say 3 weeks, and that's kind of my goal for 2025. I can certainly tell you you'll never have a 3-day sample. That would be, again, a tremendous demand. If everything this goes to the first, and we're only doing this sample. Normally they're running batches. Okay, well, here's a bunch that may be the suspect may be dicamba, so we're going to run those all together. And if we don't have a bunch, well, it's going to wait until we have a number of other samples that we're looking for the same active ingredient. All right, well, your sample goes through, and here's a bunch of them here. And we end up, and this is a willow oak, for example, a picture of it. And we end up with 28.8 parts per billion. Now, it can go down that far. In our lab, North Dakota, I know we have some North Dakotans here, can do the same thing. And you're looking at very, very, very small amounts, but it actually can get to the point where you end up with ND, not detectable. In other words, nothing was found. Problem is, herbicides degrade in plants. They can degrade out of the roots. They can have surface losses that can be volatilized off the plant. They can be metabolized by the plant itself. So the moment it's drifted onto the plant or the moment it's in the soil, now we're working against it breaking down. So let's just take an example. Let's say dicamba, and I don't mean to pick on that, but dicamba is being applied to it, and it's being applied at a certain product that's almost 50% active ingredient, and it's being applied following the proper rate. And you notice that there's some drift on the plants. In other words, within a few days, that you notice some curling in that of the leaves, so you suspect herbicide. I thought you might be interested in dicamba's half-life and foliage. Now, there's other variables than just this, so this isn't exact. But let's say at the time of application, there's my drift droplets that's actually 0.4 parts per million. That's part per million. A week later, that foliage is down to 0.2. 2 weeks, it's 0.1. 3 weeks, it's 0.05. 0.03 parts per million is the lowest number to which we can say, yes, the symptoms are caused by dicamba. A month later, we're at 0.25. 5 weeks is 0.1, and it just continues to drop. This is one reason why, for example, South Dakota Department of Ags, for their herbicide complaints, really want to get those samples within 30 days. Reason being is if you say, well, I think we saw herbicide, and you don't get around to reporting it or calling us for 2 months or 3 months, we might not even be able to find it, or we might find so little that really you could say could come from anywhere. And yes, while there are breakdown products, it does break down to something, unless it's volatilized, does not completely disappear. We're not able to trace back very well on a lot of these herbicides. In other words, we can't say, well, this sample has X amount. You said you saw the applicator do it 2 months ago. Oh, working backwards, it should have been this month. No. This is why it's very important that if you suspect herbicide drift, and you suspect it because you see some symptoms showing up in the leaves within a few days, that's the point to really say, hey, I'm seeing something. I need to know what it is, and we may be able to help you. Now, I am going to say something right now that's very important, and that is we are a state agency. If you say, I need to know because I may be filing a complaint about this person, I may be suing them, well, then we're going to send you to herbicide complaints. We do this testing for diagnostics only. In other words, to see if it's there. And what we find you cannot use in court. All right, so you'd have to go through herbicide complaints and South Dakota. They are not there to also help you file a lawsuit. What they're due to see if there was an application that was made improperly, and they'll go up against the applicator. What you may find is you need to hire a consultant who will also collect samples to determine whether it's a herbicide and how much of the herbicide was found in it. And then you could end up going to court. So it does get complicated. We certainly don't mind being the first stop. John, I'm looking at my plants. I see this. Can I send you a picture? Absolutely. Well, it might be an insect or that. Let's take a look at it. Well, it possibly could be herbicide. We might go through and do all the testing that I just showed. But if we say, yeah, we found that it was dicamba or 2,4-D or some other chemical, what we're doing is trying to help you figure out what is wrong with your plant. We're not trying to figure out who may have caused it or what you can do in the legal system to get any money award for that. That would be private consultants. But the point is, all this has to be done quickly. I'm also going to add this to everyone. If you suspect herbicide and you need to collect a sample, there's two samples you want to collect. One is where that drift occurred. Oh, my shelter belt of Siberian elms was hit, or whatever it might be. I'm collecting samples. At the same time, control samples, samples collected from somewhere else on the same plant at about the same time, which is showing no symptoms. All right. That's going to be very important for a comparison. Say we found this much in the plants that had the drift. We only found this much or none in the plants that are showing no symptoms to which no drift occurred. Look at this one. This 0.018 dicamba. You look at those leaves, that certainly shows symptoms that we'd associate with dicamba. Okay. And they suspected dicamba because of when the application was made, but the sample didn't come in until about 6 weeks later. And by that point, the breakdown of the product in hackberry is such that you're finding a very low level. And this one found none. Now, in this case, it's not even showing symptoms that I'd associate with herbicide. So in this case, I'd say there's no point in testing. We don't see any abnormal growth. This is entirely due to an insect. So this is an important one. Really, our analysis is really presence or absence. We do not have correlations for parts per million of active ingredients and injury. In other words, and this is something attorneys always ask, well, you found 20 parts per million in the leaves. What does that mean? That means we found it. Well, does that mean it can be associated with damage? Yes, but we can't tell you, oh, this many parts per million you get this damage, this many parts per million you get this much more damage, this many parts per million the plant dies. The reason for that, there's so many plants out there that are associated with drift, and there's so many other factors that are involved. It's really, yes, we found dicamba. The dicamba appeared after the plants had drift. All right, so most likely it was due to that, and the sample they collected from somewhere else does not show dicamba. So don't get too much into the numbers themselves. It's really more we either found it or we didn't. And that's why you want to collect the sample as soon as possible, certainly within 30 days of the suspected application. But here's the other thing. We all need to know what we're looking for. Is it a plant growth regulator herbicide? 2,4-D, dicamba, that. You might say, I want to look at one. I want to look at picloram, for example, what's commonly known as Tordon. Or you might be looking at an entire group, and I recommend that. And that's typically what we do. Unless you know the specific chemical that was applied, it's easier to look at the type of herbicide, and you're analyzing for all those. In other words, for the plant growth regulator, we'd say, okay, we're going to look at everything. And maybe it does have MCPP, maybe it does have dicamba, maybe it has um, uh, dicamba in it or 2,4-D, rather than going for a specific chemical. It's easier to look at the entire group. And that's why we need to look at symptoms. And so this is looking at the most common herbicides that we have. It starts out, well, was a plant injured after herbicide application or drift? And then well, what foliage is being affected, older foliage or new foliage? And then what are the symptoms? Knowing that can get us down to the type of herbicide that was used. And from that, we know what to look for. There is no universal test that you just throw a leaf in and it automatically tells you what it is. We have to know at least what the group is in order to analyze it. Was it amino acid? Was it synthetic auxin? Was it one amino acid inhibitor? Was it a photosynthesis inhibitor? And we can do that by looking at the symptom pattern. And from that, going all the way back, fragment the samples, go through, but we know what we're looking for. That's the key. We really need to know at least what is the group of herbicides we're looking at. Well, now what do we look at for symptoms? Was it a contact? Contact means you're going to find spots on leaves. That's it. It doesn't spread. It is not moving through the plant. It is not systemic. But then we also look at, well, is it one that's phloem mobile? Does it move through the phloem tissue, which carries the sugars? That tends to move up and down the plant. It tends to move to where the food demand is most, which tends to be towards the tips. And then there's also xylem mobile herbicides. These are ones that move up the plant. They do not move down. So symptom patterns are important to determine what herbicides may have been involved in the injury. So you look at contact. These are non-systemic. Diquat is an example of one. We don't see a lot of these. What we tend to see more are the xylem or phloem mobile. Xylem mobile ones is upward only. It's going to show up on the oldest foliage first. Okay, so the oldest foliage, particularly soil application, is going to find it on that. Lower leaves affected. Newer leaves will be affected in time, but you're going to see the oldest ones first being affected. With phloem mobile, it's almost the opposite. Symptoms are going to occur first on the newest foliage, everything where the sugars are being pushed to, everywhere that really is demanding of food. So you're going to see the stunted, distorted shoots and leaves there. Symptoms usually occur within days. There's Tordon on ponderosa pine just as it was candling out. And you can see all the candles, which again, where all the food was moving to push out that new growth, are incredibly distorted. Seeing that gives us an idea, we're looking at one of the plant growth regulator herbicides. Let's test for those. So let's look at them, the synthetic auxins, the growth regulator herbicides. There's three different families that typically we have. There's the common name for the various herbicides, dicamba, 2,4-D, chlorpyrifos, picloram, and I've also listed some of the trade names, not all of them. And by naming any particular one, I'm not saying that is one that we see a lot. I just pick names that are fairly common for use. All right, but let's take a look. We've got the milestones, the stinger, transline, tordon, grazon, garlands, dicamba. You could have Banville, clarity, and a number of ones. 2,4-D has lots of possible names. Dicamba is a big one. And I do want to point out, you read a lot of the labels for dicamba. Guess what? They list all the woody plants that it can be applied to kill. And I've just highlighted some of them here. Basswood, cedars, the cedars that might just stunt, cottonwoods, elms, honey locusts. One of the things you really need to look at if you're the applicator is read the label. And a lot of them will say, hey, This can be used to control brush, meaning woody plants. Well, that's probably not one you want to use around your woody plants. Now, I see this out in the hills, Black Hills, where people are applying a herbicide to kill a lot of the vegetation, the weeds, the thistle and that coming up in their ponderosa pine stand. And they didn't read the label because what the label will say, it can kill ponderosa pines. In fact, sometimes some chemicals are used at a very low rate purposely to thin out the pines. That's rather tricky. I don't really recommend it, but it is done. But that means that you make a mistake, you're going to kill the stand as well as the smaller trees. If we take a look at these synthetic auxins, it's systemic, new foliage is injured, older foliage is not initially affected. Right, what we're going to see is distorted, malformed new growth, curling of the shoots and petioles, strapping or cupping of the leaves. Now, what we're going to see is that really two of the groups, we're going to see a lot of leaf cupping and strapping. With the benzoate acids, which is the dicamba, we tend to get more cupping than strapping. If you say, well, I don't know what you mean by strapping, now we're going to take a look at some symptoms. Now, these again are xylem and phloem mobile products, by the way. So you will find them in both. They have soil activity and foliage activity. In other words, if you spray them as a drift, they can affect the plants. If they're just sprayed on the soil, they can affect the plants. And they are going to move throughout the plant, showing up first at the tips. Stem twisting, leaf formation, distortion are very common for these. Look at this, upward cupping, almost like a little cup, rain cup, if you will. This is on redbud from dicamba exposure. How do we know it's dicamba? We were picking it up in the tissue samples, and it had been done near an application. They're strapping on bur oak. We see that again more commonly with 2,4-D than we do dicamba. Doesn't mean we can't find it with dicamba applications, but let's say it's less common. Though frankly, I do see it on oaks. Twisted petioles on lilacs from 2,4-D. What I want you to look at is, do you notice how the petioles for each of these leaves is curled and slightly twisted? That's a very common symptom for synthetic auxins. It's not just drooping like you may say occurs with drought. It's that droop and a twist to it. You see that quite often. What you're looking at is drift from a synthetic auxin herbicide. Now these, again, this was an aerial application of dicamba made at the same time the ponderosa pine and the shelter belts were breaking buds, the most vulnerable time period for the trees. All that new growth is pushing out, which is very sensitive to dicamba, any of the synthetic auxins. And you see all the twists, all the abnormal shoots there, and the needles are down to little stubs. And quite often we find dicamba and 2,4-D. They're often used in a lot of herbicide formulations. In this case, we found 0.05 parts per million of 2,4-D and 0.02 parts per million of dicamba. And you might say, but John, those are fairly low. You're right. They're low enough you don't associate them with this damage, but the samples weren't sent in till 6 weeks after the application. In other words, they weren't collected till 6 weeks after the application. That's about what I really would expect to see, because dicamba is broken down very quickly as a relatively short half-life. But there's other things that mimic herbicide. Ash anthracnose. Last spring we had a wet spring, dry summer, but wet spring. So there were a lot of ash in midsummer that were dropping leaves, and the leaves as they were dropping were twisted and curled. Now the petiole wasn't curled though. So this is just a fungus disease. Ash leaf curl aphids. They occur at the tip. They twist all the foliage like this. It gets very bunched. Now, if you pulled it open, Most of the summer, you'd find aphids in there. They're living in there. But I had people that looked at this and said, you know what? I saw somebody spray, and I went out and looked at my trees in the shelter belt, and they all have this twist to them. It's got to be them. No, it's actually an aphid. It's not any herbicide drift whatsoever. Now, again, doesn't mean you can't have two problems, an insect disease and a herbicide. But in this case, there weren't any symptoms that I would associate with herbicide injury. So there was no point going down that road. Oh, and I love this one. That's contorted white pine. It's supposed to look like that. You pay extra to have it look like that. It was a new homeowner and wanted to know why all their pines were so distorted. What were their neighbors spraying? Neighbors weren't spraying a darn thing. The people who lived there before bought the plant to have it look like that. So we also have cultivars that, quite frankly, look like they'd been sprayed by herbicide. Well, we also have to look at the half-life in the soil. They persist longer in the soil. Now, it depends on the soil characteristics, how much organic matter is there, which tends to bind the herbicides, so they stay longer in the soil, the texture of the soil, finer soils, and how much biological activity, because many of our herbicides are broken down by microorganisms. So the more favorable the environment is for soil microorganisms, a soil that's adequately drained, for example, little organic matter to it, is going to break down quicker than a poorly drained soil or a soil that stays very cold. But I want you to take a look here, and you'll notice that a lot of these, look at some of these. Tordon, for example, its half-life can be as long as 300 days. That means the amount you start with, almost a year later, it's only half of that. And then another three, it's half of that. That's the extreme. Sometimes it can only be 20 days. Depends on the soil microorganisms. But my point is, you're usually going to find herbicides, if they're applied to the soil, persist longer in the soil than what you would get on a herbicide drift that only touches the leaves. So let's look at some soil. This was HOA, where somebody had gone in and applied 3-Some. 3-Some has dicamba in it. Now, interesting enough, the label says not to be used in residential or landscape areas. It's only supposed to be used on sod farms for ornamental applications, but they used it here. And you see that pattern, how it twirls around up? That's very common with soil. So I looked at that and I go, that's a pattern that looks like herbicide. And I could see it on conifers throughout, as well as some of the deciduous material, but conifers were really impacted. And I said, what was sprayed here? And then we went back, found the product. The applicator told us, and look how much dicamba we pulled out of that. 1,120 parts per billion dicamba. They were almost glowing. It was very easy to connect the dots here, cause and effect. Symptoms occurred very quickly. We're able to analyze it very quickly, and we're able to find that amount. The trees actually continue to decline. The label says not to be used in this application. All the dots were connected. Dicamba half-life here in the soil. Look at how long it can persist. Notice a June 1st application, it's persisting till the following year. Now, only 3% of the levels left, but nevertheless, you can have some plants that can be affected for an entire year from an application made to the lawn, for example. And we get a lot. Look at this. This is in Pierre, South Dakota. And some of us went by and looked, and here's all these dying ash. Well, dying ash, what do you think? Well, you think of emerald ash borer, of course. But what was interesting, it was just the ash associated with this yard. That's emerald ash borer in Canton, South Dakota. And you can see that dieback, but you can see it occurring on trees all the way down the road. And you can find the larvae inside it. Well, there was nothing in the trees in Pierre. but look at how stunted that growth is on the shoots at the base. So I asked the homeowner, have you sprayed anything on this lawn? He goes, no, 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 I haven't sprayed a thing. Have you fertilized? Oh, yeah, I fertilized it. Well, there's the weed and feed product. And notice what it has? It has dicamba in it, right? So, and it was enough to affect the plant material. So weed and feeds have to be looked at very carefully. I wish people would just buy the feeds, not the weed and feeds, or be very careful. And had he read the label, and I recognize most of us don't, it says right on it, don't use it around any desirable woody plants. Or this one that I saw up in Sturgis, South Dakota. Look at this ash here again that has all the distortions on that. Well, it showed up after they had applied their fertilizer, which again was a weed and feed product. And it said right on the label, I still had the product, it says right here, don't use this product within the drip line of any roots of desirable trees. Injury may result, but I have a problem with drip line. Some labels are actually changing this now. There's nothing magical about the drip line. Tree roots go out much farther than the edge of the canopy, their quote drip line, particularly on conifers, which tend to have a fairly narrow crown. Roots extend out about as far as a tree is tall. In other words, if you're applying a product that says don't use around desirable trees, I don't care if they say don't use it within the drip line. Don't use it within a distance equal to the height. Quite honest on that one, because it'll pick it up that far away. And some labels are changing to say that. And this is so important with conifers, particularly small spruce in that. You know, you see a 12-foot tall spruce that has a 5-foot wide uh, canopy. Well, I shouldn't use it underneath it. Well, you're probably not able to get underneath it to spray anyway. But if you're using within 12 feet, you can kill it or severely stun it. Well, let's look at some others that we have root issues with. These are the amino acid synthetic inhibitors, and we have a number of them, but I see mostly not drift problems, but root problems. And on these, stunted plant, shorter internode, chlorosis will show up. You can actually get some purple veins appearing. Growing tips may be flat out killed because you can see the new growth affected first. These have soil and foliage activity and stunted leaves. Now, in this case, symptoms are slow to develop. It might be a week before you notice anything. They're not as quick as the growth regulator ones. But look at this one. This is from Pierre. Went out and took a look, and here's linden trees that aren't doing very well. They're dying back, and it occurred relatively quickly. Noticed it after a couple of weeks from an application. The application was done to all the pea gravel underneath the tree. You don't see any weeds, do you? Well, I said, what did you apply? And you still had the bottle. There it is. This is called ground clear. It'll kill any woody plant as well as most weeds. You didn't read the label. Do not use it underneath trees. And flat out smoked the trees that were in the pea gravel. Escort. See this sometimes. This is actually in Hot Springs. Someone had applied it to kill weeds. It should not have been used in town the way had been used here, but saw the dieback on it, found out what the product was, tested it for this type of herbicide, the amino acids, and sure enough, pulled up Escort. So connected the dots. Again, the amount we found isn't as critical as the fact that we found it. By the way, glyphosate used to be included in that, but now it's actually in its separate category. We know it as Roundup, of course. On these, we'll get chlorosis on it. We'll get necrosis, actual dead tissue. It's a non-selective. The youngest foliage often becomes yellow more sooner than the older foliage. Why? These are flow mobile. And while we don't really get a lot of movement, we certainly can. They only have foliage activity, of course. Glyphosate applied to the soil doesn't really affect much because it binds very quickly. But the symptoms are yellowing of the foliage, and then, of course, necrosis. The foliage actually dies. Usually you see this within a week or two showing up. There's glyphosate as a spray drift. You can see the dots, the leaf spotting. Look at this. Notice how it's yellowing? This is on lilac, where glyphosate had been used in an adjacent field, and we were able to pick it up. Now, by the way, glyphosate's unusual and that's very stable. And in conifers, we can pick it up 2 years later sometimes. So it doesn't break down as quickly as many of the other herbicides do. But I put this up here because this is important for all of you. Everyone associates glyphosate with Roundup. Roundup is a name that they own. They can have anything they want. Look at this. Roundup for lawns. Kills weeds, won't harm lawns. But look at what it contains. It doesn't even contain glyphosate. It contains dicamba in that. And I've had homeowners that contact me because they say, I've been using Roundup for years in the pea gravel underneath my trees, crab apples and that. And then this year the crab apples died. Well, I said, take a picture of the Roundup you bought. And it doesn't even contain glyphosate. So just be aware, Roundup is a name. It's not a product. And you still have to read the active ingredient list. And obviously read and follow the label directions, because what you used to think of Roundup isn't always Roundup today. Now, there are some formulations that still have it, but this is causing a lot of problems as of late. We also have photosynthesis inhibitors. Atrazine is probably our most common one there that we see injury with. With these, you're going to get the older foliage. These are non-systemic. Older foliage is going to be affected first. New leaf foliage is not initially injured, and because these are xylem mobile products, and they do have soil activities, and they're fairly slow to develop. Here's Moxie carryover on linden, and you can see that kind of modeling in the foliage. Half-life in the soil, it can last a long time. This is atrazine. Say the application was made in June, you still have quite a bit of the product in there in September the following year. The following year. The other thing with these is you will get interveinal yellowing caused with the death of it, but here's an important thing that you want to look at. You can get a lot of things that people confuse it with. That's island chlorosis on hackberry. That's a viral disease, not herbicide. You get chlorosis on Freeman maples. That's due to an iron and manganese deficiency. It's not due to a herbicide. What we find is the herbicide-induced chlorosis is usually more uniform with sharply defined green veins, where on others like this iron deficiency on northern red oak, notice how it's a little bit more gradual. It's not just a uniform color change in the foliage. You'll notice it's a little lighter in some areas, darker in others, and we've got that dark green line running along either side of the veins. So not all chlorosis is herbicide, but some chlorosis is. And we get carryover. This is atrazine carryover on cedars, eastern red cedar. By the way, remember, it can last for a couple of years. This had atrazine planted for corn. The following spring, it was planted to cedars. They all died. The next year, they planted them all to cedars. They all died again. And when I tested it, I could still find a lot of atrazine. Again, the fact that I found it at all was enough to kill. So we have carryover injuries too for planting smaller trees, not mature trees. They would take it. In this case, Triflex 2 years carryover. Atrazine 2 years. Cornerstone, no issue, and these are no issue because these are surfactants. But I've told conservation districts, and they're well aware of this. Biggest thing you want to get if somebody's planting a shelter belt, what chemical was used this year? What chemical was used last year? And that'll tell us what and when a new shelter belt can be planted. And as an example, and by the way, we have a fact sheet coming out on this. I was hoping it would be done in time for this. It's not. It's still held up a little in our publication, but I'll make sure that we announce it in the pest alert when you'll be able to download this, because we've listed all the chemicals and how long you have to wait for carryover based upon soil conditions in the plant. Notice dicamba, 1 or 2 years, 2 years certainly for legumes. Notice if you're doing broadaxe or authority, 3 years. Pursuit can be 4 years under some conditions. Here's some dicamba carryover. Notice how we're getting that bleaching out of the plants. Corn, atrazine, 2 years, some 3 years here. Triplex, as I mentioned, is 2 years. This was an interesting carryover injury. I went out there and looked. It was corn, and atrazine was used the next spring, planted it into cedars, and I looked at it, and I told the producer, I said, you shouldn't have done this. And he said, yeah, the district told me I shouldn't do this. Well, you should have followed their advice. So again, we're all human and we make mistakes, and sometimes we have to pay steep tuition like this. But what was interesting is I was able to find 112 parts per billion of atrazine from an application made 18 months earlier. Again, 130 is where we see damage, and there had to be more than 112 at the year it was planted, and everything went south. And then we also look at some milestone, Grazon, Tordon. I want you to notice on these, it can last 3 years for Tordon and Grazon. And this is for new plantings, but we've got to be kind of careful about some of these. There's picloram carryover. It was a pasture. They planted it into woody plants the following year. Every plant was dead, and I looked and I said, what was used last year? And they'd used picloram, Tordon. Pretty good burn for thistles, but it will persist in the soil for up to 3 years, depending on soil conditions. And our new guide will go over that. So I'll finish. We may have some questions. I wanted to make sure I finished up at about 10 to the hour. That's how you can reach me, john.ball at SD State. Sorry about that. I forgot the T. It's ST State, STATE. And there's my cell phone number. I carry it with me all the time. It was off right now just because of the fact I'm talking to you folks. But there's the information. By the way, for everyone here looking for ISA CEUs, and again, you can only get them from the live presentation here. The title is Herbicide Carryover and Drift. Herbicide Carryover and Drift. The code is DS-25-010. And I thank Scott for up in North Dakota for getting me our codes all the time and making sure any of the members that have ISA certified arborists or board certified master arborists are able to get that code. So with that, I'm going to stop sharing. I think everybody's got that information. And I'll go to Tony if there's any questions that people might have. We got a few minutes to answer.
We have a couple questions in the chat box now. The first one comes from Matt. Matt is curious why the results from your lab would not be admissible in court. What differences between labs could play a
Oh,
role
okay.
in that?
That's an excellent question, Matt. And here's the reasoning. We're a state agency. We cannot choose sides in legal disputes. Why? Because we're paid by everyone in the state. We certainly want to help out. Sometimes we look at it and say, that may be herbicide, and we go through and analyze it for that. But I always try up front with people and say, look, if you're looking at having a lawsuit on this, you'll need to hire a private consultant. And in many cases, they have to do their own testing. And by the way, if you contact the South Dakota Department of Ag Natural Resources and file a herbicide complaint, which you can do online, same thing there. I have people call me, well, they did everything and I never heard. Well, remember what they're doing is they're going to maybe cite the applicator for an application that wasn't following the label directions. Once again, they're not there to pursue any legal case. So I've had it before where I've gone out to people and said, yeah, this does look like drift. You say your neighbors applied X. The plants that I'm seeing do have these symptoms. So I would suggest that if you want to pursue this, that you contact a individual who does these cases, and we have them in the state because they can do two things for you. They can take a look at, well, was the herbicide present? And then also what loss you had in your shelter belt, for example. One reason we don't do this is rather an expensive process to do. And I can remember 15 years ago where we did help landowners a little bit further. And I can remember one case where we probably spent $800 testing one property. That blows a budget very quickly. And quite honestly, we were getting calls from people, well, I'm pretty sure it's herbicide. I want you to test it for everything. Sure, that'll be the one we do this year. So again, please feel free to call us if you believe it's herbicide drift or send pictures and we'll give you an opinion. That's certainly what we can do. But if you need to file a complaint against someone, or if you are looking at it going to a lawsuit, you are going to sue someone, you really need to hire um, private consultants to be your expert witnesses. We cannot be an expert witness in court cases. There. Hope that was clear.
Our next question comes from Patricia. She's curious about shelter belt preparation, tilling the land, and then is there a chemical application recommended for weed control? What would you encourage somebody, I guess, without knowing much, to assist in windbreak management or preparation?
Very good. That'll be a segue into one we'll be doing here this spring because there's two questions. What can I use to prepare the land? And then what can I use, for example, right around the base of the tree? And by the way, it differs whether it's an established shelter belt or one you just planted. We do have products that would be damaging to a newly planted seedling, but we do use them around plants. So that's a little bit more detailed question, but it's an excellent question. Okay, well, herbicides can be bad, but they can be very helpful. So we'll try to give you kind of, and along with a fact sheet, what chemicals can be used in your shelter belt when you're establishing one, and what herbicides can be used in established shelter belts. Stay tuned.
That's all our questions. So unless there are any more that pop up here, well, thank
Well,
you.
it's
Dan
probably
West says thank you.
all right. Well, it's a depressing one too. But and again, folks, I do want to point out that we do get samples in or pictures in where I say, no, I'm sorry, this isn't really any herbicide at all. And then we do get them where it is clearly herbicide. And in some cases, we'll say, well, just to be sure, we're gonna analyze it. And we find out it's X amount in there. By that, we found it in high enough levels that it probably wasn't just some drift from anywhere. But here's one problem. We can't tell you who applied it. We have no test that says it was them. And so it's difficult to do. I am not discouraging people from filing herbicide complaints, but I am going to finish with this one too, Tony. Here's my one bit of advice. If you had drift in town, which we do get too from adjacent fields, or you live next to an ag area and you had drift on your shelter belt, The one thing you never want to do is if everybody gets together and says, let's wait and see how they look next year. And here's why. You wait till next year. Next year, the plants have died back. And they turn it over to their insurance company. Insurance company says, this could have been winter kill. This could have been dieback from drought. And guess what? In a lot of cases, you're going to find so little chemical in there at that point, it would be impossible to say that even if they sprayed, that what you found in there could have caused damage. Now, again, it's presence or absence, but how do you know somebody else might have applied somewhere and you got drift and you got that little in it? So here's the rule. If you suspect herbicide drift, if you're going to do something, do it then. At the very least, send a couple of pictures. We'll let you know if it's possibly a herbicide. If it is something you want to file a complaint about, South Dakota Department of Ag and Natural Resources does have on their pesticide ag services that here's where you file a complaint. But remember, the complaint is against the applicator for what they may have done that was illegal. It's not that you might have gotten some drift on your land necessarily. But there are experts in the state that will handle those cases if you are looking for a monetary settlement. But do everything soon. Waiting, especially beyond 30 days, really reduces your chance of a successful recovery.
That just about brings us to the top of the hour.
All
Thank you,
right.
everybody, for attending today. One more call for any SAF certified foresters. If you wish to get a continued education credit, please put your SAF certified forester number in the chat box here before I end the meeting in the next couple minutes. And then for those of you interested in more forest health workshops, I guess. Stay tuned. April 9th, Wednesday, April the 9th is our next scheduled workshop. We'll be discussing spring predictions in our area, in our region. And then we'll have another one in May, and we'll keep the ball rolling. As long as you all are interested, we're going to keep on doing these workshops. Feel free to also send us potential topics if you wish. We're always
Please. Yeah.
interested in hearing what you are all seeing across the state and in our region. So thanks again for your time, Dr. Ball. Thank you, and we'll see you on the next one.